thanks everyone for joining in today. Just firstly, we're aiming to run this webinar for around 30 to 40 minutes. And we're going to be looking at the handling of lupin seeds and the impacts mechanical damage can have on the germination. So just a bit of background around this project. I guess the issue came from a GRDC grower network discussion probably around 5 years ago. There were some concerns, I think, out of the 2017 season around split seed in lupins. So there was a few projects funded by GRDC, and we were funded to do a benchmarking study to see what was actually happening in the field in terms of lupin germination percentages and how lupin seed was being handled by growers. So the majority of this work was conducted in the 2019 harvest and into the 2020 seeding. We did continue it and do a smaller subset of growers in the 2020 harvest and did a bit of work into 2021 as well. We're now at the end of the project and we're basically just wanting to share a few of the results with you all today. We thought it was a timely opportunity to do this, given we're leading into the 2022 harvest. So we're going to share some of the findings from our benchmarking, and we've also got Glen Riethmuller from the Department of Primary Industries and Regional Development here today, who's going to share some of the practical tips and tricks to handling seed, in particular lupin seed. Just to note that this webinar is being recorded and we'll make it available on the Liebe website, and it's likely we'll rerun this again at different times throughout maybe next year at key times. And I just need to thank GRDC for the funding, and also DPIRD for their support throughout the project as well. We've run a number of workshops and we've had really good support from DPIRD researchers, so we appreciate that. I'm going to give a bit of an introduction and show you some of the data, and then I'm going to hand over to Glen, who's going to be sharing some of the tips around handling seed. Before I go into that, just if there is any questions, feel free to either write it into the chat or just jump in at any time and ask it. So just a bit of a project outline. The benchmarking study we completed was of 27 lupin paddocks in 2019, which we repeated with a smaller subsection of 6 growers in 2020. That's the harvest of 2020. We collected samples from each of those paddocks prior to harvest and post-harvest, then again prior to seeding and post-seeding. And they were all sent away to DPIRD seed testing to give us a germination percentage. One of the notes, we did try to do some backyard germination testing with the aim of comparing what we could do at home with what can be done in a lab. And the resounding result of that was the backyard germination testing failed. We had all sorts of problems with seed going mouldy, and trying to do it in February, it was really hot, so keeping moisture levels at the required amount was really difficult. So the message here is definitely use industry standards. It's a quick turnaround test for germination, and it gives you a really accurate result. We also did some rotor speed testing with 4 growers. We didn't find any significant differences in rotor speed and the impact on germination. And we also did some auger journey experiments, which we'll talk about a little bit later on as we go. Here's just a couple of photos of a couple of the growers that were participating, and we're just bagging up some lupins. It was quite an intensive sort of project, and we were collecting a lot of samples. So we appreciate all the growers that that were involved and their time. So what did the results tell us? So from the 2019 harvest going into the 2020 seeding, we saw a decline from the pre-harvest samples that we took, which were threshed by hand in our lab. Most of the pre-harvest samples came back, pretty much all of them came back at around 96% germination, which is pretty good. And from there we saw a bit of a decline down as that seed was handled more, till we got to post-seeding, which was the sample was taken from the boot of the seeder, where we were down to about 76% germination on average. One of the things that I noted out of that data was that the range of germination percentages at post-seeding was pretty high. So there were some samples or some growers that stayed at around 90s, in the high 90s of germination, but there was others that were down at 50%. So there was something going on there. Difficult to unpack exactly what process caused that decline with each of those. There's a lot of variables, obviously, when you're doing this sort of work. But yeah, quite obviously, with that data, there was a decline, and it's likely the compounding effect of all the different handling techniques has probably had an impact come seeding time. So, like I said, the germination percentage range was at post-seeding was between 50% and 96%. Across all those samples, the grain moisture at harvest was 9.5%, and the average manganese content was 0.19, which is all of them were above the threshold, which I think is 0.15 for manganese content of the seed. So this was just a summary of the varieties. We had Barlock, Karamup, Gunyeti, Durian, and Mandelup. We had a lot more durian growers in the benchmarking. I would sort of caution this data. It is benchmarking data. There is a bit of a trend towards durian and Mandelup having lower germination percentages, but correlation doesn't always equal causation. So I'd take it with a grain of salt. It might have just been that some of the growers were more harsh on them with their mechanical handling that were growing Mandelup. So it wasn't that much of a controlled experiment. But I thought I'd just show the summary of the varieties here. In the 2020 harvest with the 6 growers that we continued on with, there was again a slight trend at post-seeding, average of around 83% at post-seeding compared to 90% at post-harvest. We didn't take any pre-harvest samples on this occasion, but there's still that downward trend. That leads us on to the auger journey experiment. So what we did here was we had a seed source. In this instance, it was durian lupins with no manganese applied. And we ran the seed through 2 different augers. We ran it through 10 times, taking a sample at the end of each auger journey. So what this is showing us here, we're looking at a range of germination percentages from 99 down to 93. So it's all above sort of recommendations for germination rates, albeit there is a slight decline there, and slightly more pronounced with the older auger as well. And Glen might touch on some of the older work that was done by DPIRD in relation to auger journeys and quality of augers a bit later on. We did repeat that again with a different, it was a separate experiment really, but it was with a Gunyeti seed source with manganese applied. And almost a straight line there between auger journeys, 95% down to 94. So nothing really to be concerned about there. It's a bit difficult to compare the two experiments given they were separate seed sources. It might have been nice to compare a similar seed source with and without manganese, but that's not how we did it in this case. So they're really treated as two separate experiments. So that's pretty much the summary of the data. I just wanted to just give the Harvester Setup Workshops a plug, which is part of a harvest loss project, before I hand over to Glen. So these are happening next week, one in Merredin, one in Dalwallini, and one in Chapman Valley. There'll be sort of 4 hours of hands-on practical demonstrations around setting up harvesters. So relevant to this project, but also from a harvest loss perspective as well. It's really important. So that's pretty much all I've got as an introduction. I might hand over to Glen now, and he's going to take you through some of the practical tips and tricks.
Okay. Yeah, thanks, Chris, for inviting me to do a chat on this. If I disappear, the lights go out. Here we go. I don't know whether you can see my cursor on the screen or not, but that could be handy later.
Yes, we can see it. You
can see it? Excellent. Right. Well, I'll just touch on a few issues. I'll start on some of the older germination work, which I think is still relevant, and then move on to a little bit of the harvesting stuff as well. Ed Blanchard did some work back in '94, looking at this germination problem for harvest through to seeding. And the upshot of that earlier work was really the seed had to be above 11%, really, because anything lower than that, it's interesting that you got 9.5 average, because the lower the moisture, the more damage that can affect the seed and certainly crack it or damage the coat, that you can't actually see any problem, but it actually damages the inside of the seed, so it doesn't germinate so well. Keeping the peripheral speed of the rotor to less than 12 meters a second was also handy, and removing every second wire. It's interesting that he did a heap of work on augering and very little effect on germination. It's a bit like what you found there too. This is example here. I don't know. Oh, my mouse won't show it now. Just with these danger lupins, peripheral speed there of 15, 20, and 25 and 30 meters per second. Now, when you're harvesting cereals, you're up around the 25 to 30 meters a second. But as the moisture of the seed dried, the germination percentage dropped a lot. So you can see there, if you have high impact speed of 30 meters a second and 9% seed, you're only getting 70% germination. So admittedly, you wouldn't have been using 30 meters a second, but see, even at 15 or so, it still brings it down. Now, he concluded that 12 was a good cutoff, that you didn't lose too much if you stayed with 12. Now, an example of what the current harvesters say, I just look at 12 meters a second and what rotor speed each of these headers here is. So the case is only 300 RPM. The New Holland's a slightly smaller rotor, so it's a bit higher at 410, and the others are still around the 300. So it's fairly slow rotor speed to get that 12 meters a second. Now, there's always a compromise in harvesting, and that's capacity. So if you've got a big crop, a big bulk of material, you tend to still want to keep the rotor speed up a bit. Otherwise, if you get a slug, it can actually kill your motor. So some people would err on the side of higher than lower. But if you've got a big crop and just not a lot of grain, well, then it's cushioned by the crop anyway. So the damage to the seed is probably less anyway. So that's just like a suggested minimum anyway. Here's an example of the wide web. The front concave there was the standard cereal concave. In this case, just happened to be field peas, but the peas just pretty well block that cereal concave. So you don't want that to happen. So for lupins, you really need the wider open area to let the seed out. Otherwise, it stays in there longer and more chance of damaging it. Some more things from that work. Don't store the lupins with green radish, which lowers the germination. And use a minimum airspeed on the air seeder and a minimum impact primary splitter. By that means that some of the splitters on some air seeders are reverse impact. So, and if they've got a hard top, you can actually damage the seed if you're putting a very high airspeed on, say to stop blockages, but then your hoses, if they're not all going downhill from the head itself to the tine, you can get away with a lower airspeed if you do that. If it's a nice downward trend all the way, you can get away with a lower airspeed, and that'll damage the seed less. And he found that with those, particularly air seeders that have like a splitter like your hand, goes along and then splits into, say, tubes going out horizontally rather than in reverse impact, those splitters tended to have less damage to the seed than the reverse impact. Measuring, of course, the germination before seeding, because once you get down to 75%, the seed is probably not that great anyway. So your vigor is also lower. So low germination percentage is one thing, but vigor is another. So generally, they recommended not to use it under 75%. Now, there was a thought he tried this electrolyte solution test, which only takes 24 hours. And in soybean, there's been shown to relate to field emergence better than germination percentage. So we thought, here's a go. Here's a nice quick test. And all you do is drop some seed into a distilled water sample and then test the electrolyte solution for how many salts are in it. And so if it's got a slightly damaged seed coat, it'll leak out salts into the solution to be measured. But unfortunately, the two experiments showed really no relationship with field emergence, but 3 did some a little bit. So he concluded that it might be worth further investigation, but I haven't seen any other work on that since. But also soybeans have got a thinner seed coat than lupins, so I suspect that might be part of the reason we didn't have so much luck with that. It might be relevant to field peas because field peas have a thinner coat than lupins. Don't keep rain-affected lupins for seed because the wetting and drying can reduce the germination. And in that work, where he did higher seed rates of 80 kilos a hectare, had a better germination than the 40, and that could have been the cushioning effect from, say, extra seed and fertilizer, perhaps in the airline, might have reduced the airspeed a bit, and also the cushioning of seed on seed might have had less effect on the damage to the seed. Just an example here that from Marty Harry's talk about how rain can affect seed. On the right-hand side there, you've got Wayne Parker looking at some seed that's harvested after rain versus before the rain. So it's definitely better seed. I guess that's what he pretty well found. And then that's in 2005. And then, of course, in 15 and 16, there was 40 mils of rain, I'm not sure, during lupins. So that can still happen at any time. Could happen this year again. So that's something to be aware of. This experiment that Marty did, looking at wetting and drying cycles with only 10 millimeters of rain. So one cycle dropped at 5 to 10%, 2 cycles 10 to 20, and 3 cycles up to 45%. So certainly the wetting and drying cycles is not good for lupin germination. Now, I couldn't find any storage stuff for lupins as far as germination, temperature, and moisture, but I did find one for soybeans by these guys in Brazil. So at this storage temperature of 20 degrees in a silo, and say, I've actually had an aeration silo here on some canola in December, and I got the seed down to 14 degrees temperature. So there's not a problem to get down to 20. It's easy enough. People think that you'll never get it to 20 in December, but you can because it's pumping in cooler air from the morning. When I jumped in the silo, my feet just about froze. I couldn't believe how cold the seed was. But anyway, here it's say 20 degrees Celsius. The top lines there is the drier seed, the 11.2%, and then the 12.8%. So that's no problem. But when you get to 14.8% moisture, then the storage, the germination dropped off with time. That's at 20 degrees. You go up to 30 degrees, and of course, then they all started getting affected. Still the best was the driest, 11.2 was still the highest, then 12.8, and then the 14 is less. And of course, once you get to 40 degrees, well, then they're all pretty sad. It's a good thing that I guess your survey there was 9.5% average, but there could be a few moist ones in there. But certainly you wouldn't want to keep it warm in a silo if it's still a bit moist. As a general rule, now this is from the GRDC Grow Notes, they suggest should be stored less than 13%, which is fair enough. And keep the temperature around 20 and certainly below 25 if you can. It's advisable not to store with any contaminated green pods like with wild radish. Here's an example from Marty's work, I think it was, with manganese in the seed effect. So when you get really low levels of manganese, you get split seed and therefore lower germination as well. But I think your samples are all okay. The high temperatures can volatilize those toxic compounds in the radish pod, which can kill the lupin seed, and that can happen fairly quickly. So even temporary storage can be damaging. Even a few days, they said, was enough to damage the seed. So that's something to watch out for. Hopefully we haven't got too many radish in our lupins anymore, but if it does, that can be a problem. Interesting, painting silos white. I've seen more of that in Queensland than I have over here, but it can actually keep the grain inside 4 degrees cooler. The problem is cost and how to do it, because most silos are delivered in their shiny steel, and yeah, painting it white costs as well as takes longer and costs more. The bigger silos generally remain cooler because the small silo has got more tin work compared to the same tonnage, say, than the big silo, so they tended to stay a bit cooler. Just moving on to some practical stuff on harvesting now. The one way to certainly check that you're not losing grain out through the harvester anyway is these drop trays, and this is an example here of one from Primary Sales, but there's a few different ones on the market. So you're simply driving along, have it all set up nicely, and then press a button and it drops the magnets from a tray onto the ground. And then as the harvester goes over it, the seed and rubbish gets collected in the tray, and you stick it through a little cleaner and measure how much grain is there. So without measuring the losses, you really have no idea what's going through the harvester. But the front end is probably the most critical thing with lupins. And this is where our earlier work found that certainly reducing the shaking of the stalk with, say, double density knife guards there on the left-hand side was better than the standard 3-inch, which pushes the stem a long way to the side before it's cut. And that shaking is what seems to break the pods off before it even gets into the front. And another problem with the knife, and this is from a brand new machine at the Darren Field Day, the left-hand arrow there, you can see the knife section is cutting on the right position there on the knife guard itself, like a pair of scissors, so it's flush with that. The arrow on the right, you can see the next little guard there is a couple of mils higher, and the one further over is at the top as well, and that's not in the best position for cutting. That'll tear the plant off, and if it's got to tear it off, chances are it'll propel it forward as the motion of the cutter going forwards will tend to tear it, and that tends to fly the pods further forward too. So it doesn't take much to get these guards can be altered. Say if you hit a rock, that's what happens, but then you can just bend them up. And talking to quite a few of the dealers, they say there's no problem of putting a lever on there and just bending it up, because it actually bends the support at the back, not the actual guard itself, because the guard itself, they're quite hard material, but where it just bends that little guard at the back, and you can get that knife back nice and flush again. This is a raised knife kit on a belt front, and you can get, this happened to be Primary Sales extension fingers. You can get the pink ones there that are straight, which is what we were using on our case front, but some of the fronts like John Deere might have the knife angle might be lower or pointed down more when it gets low to the ground, so they're angled ones, the blue ones there, help catch pods on the knife sections that are more tapered downwards. The air reel is an interesting one because they really do work. This is the Carreri reel was originally made by Harvest Air in Perth, and then they had it, I think they sold the patent to Carreri, and now Carreri are making them, and they're bringing them back in via primary sale, via Harvest Air again, sorry. And so the people that have these reckon they're great, and the advantage is that you can just lower those air tubes down when you have a low crop and lift them out of the way when you have a big crop where they're not needed. So it's the best of both worlds. But like everything, of course, it costs. But if you've got big area lupins, it's I reckon it's worth a look. We did try in really short lupins, these this black core flute a few years ago. I had one piece per turn of the reel going round just to sweep it off the knife. But there's better material on the market now. You still can, or some people tried brushes. I think Bob Nixon tried these brushes, but the brushes tend to catch material in them, so and it's not as clean, and it should be black as well, so at night time you don't get reflection in your eyes from the lights. But this 1.5 mil high density polyethylene sheeting is a handy thing to put on the finger tine reels just for really short lupins where you've got a problem. This is Dylan Parkhouse at Kellerberrin. He put them on every one of the sections of the reel, which I thought, you won't be able to see the knife, because we tried that and you can't see the knife. But he said, well, their machine has height sensors anyway, so the front can float along the ground, so he didn't need to see the knife. But driving along beside with his dad was, you could see that any pods that were being flown forwards tended to catch on those pieces of sheeting and flip back in. So he thought it was still better than nothing. And there it is, just zip tied onto the reel, and you see those pipes underneath there are the that's the sensors for the height control. And yeah, but if you take them off for bigger crops or cereals, because that edge coming down into the crop could knock more, like barley or wheat heads off. So you'd take them back off again for the normal cereals. Moving on to how to keep the grain cool. Now, there are different aeration systems on the market. I've just picked on one here, and they make them so that they can blow in the coolest air of the day. I tried it at Meriden just with a timer, and I managed to jag it, but you have to be checking the temperature all the time, whereas this automatically does it for you. And there are bigger models that can do several silos at once, so they can, same thing, measure the humidity and air condition, and then blow in the coolest air for the time of the day. You do have to have electricity, of course, so that's one of the problems. And certainly we have some nice pink and grey cockies that just love chewing plastic, so that needs to be covered pretty well if there's wires leading up to a silo. They also suggest using ventilation in the top as well, because if you're going to aerate it to cool it, you've got to have airflow. So these lids that they have, they automatically seal again when the air's turned off. So then you can gas your silo if you're putting cereals in it. And I think that's about it. Now, just a few thoughts, of course, just keeping the harvesting as early as possible. You can deliver at 14%, but I'd say aim for 12, that keeps longer. And other work suggests if it gets really dry, it can develop hard seededness. So if it gets too dry, it takes a bit to wet it up again. So you might get, staggered germination with the lupins. Of course, the adequate manganese fertilizer is important. Harvesting at night or when the humidity is high to reduce that pod shattering is certainly a good thing to do. I suggest calibrate the yield monitors, not only for yield, but also for that moisture, so you can actually see that you can start earlier than you think. And don't keep rain-affected lupins. Paint the silos white if you don't want to go cool it, or if you want to cool it without having to use aeration. But certainly aeration with automatic controllers is the bee's knees. And I think that's about it for me.
Okay, thanks. Thanks, Glenn. One of the things that I've been sort of thinking about in this space is the compounding effect of different processes. So when we did our rotor speed experiments, where I think we had 4 growers harvest their lupins at a low rotor speed of 300 up to around 600 RPMs. We didn't really see any differences between the two, but I sort of wonder whether over time, if you harvest at that higher rotor speed, and then you're putting it through lots of augers, and then maybe at seeding time, it's sort of thrashed around a fair bit, whether that compounding effect actually leads to a poorer germination in the paddock. What are your thoughts on that?
Yeah, I tend to think that can be the case, because you might find that, yes, it can sort of, that higher speed can just damage the internals of the seed, and you don't see that until later on after the storage time. So, and also in that case where you did the rotor speed thing, I don't know whether your seed moisture was measured there, but if the moisture was a bit higher, that would cushion the effect of the increased rotor speed. Like I said in that diagram there, if you have really dry seed and high rotor speed, that's where you get most of the damage after it's been stored. You don't physically, you don't see any problem at all in the seed coat. It's just the storage time, whether it's the temperature and condition in the silo, but that effect does carry through. So I think it is a cumulative effect, that you look at the seed and think it's fine, or test it straight after the impacting it, think, yep, that's good, but the time can be the killer.
We certainly found in the post-seeding collection, where we took it from the boot, that was our steepest decline from pre-seeding to post-seeding. So I think you might be right with the seeding systems as well. And one thing that Rob mentioned, I think Rob's still there on the webinar here today, it was the tubing as well, air seeder tubing. And the quality of that can make a difference.
Yes, well, some tubing is fairly smooth inside. Some have gone to rubber tubing, thinking it was a better material for impact. But the trouble with rubber is that it's got a higher friction coefficient, so you generally have to put a higher airspeed on to push it through rubber hosing. And so that can have an effect. And also bends, every time it takes a bend, you'll tend to notice your air seeder tubes tend to wear out on a bend. Why is that? Because it's rubbing it harder. When it's the seed goes to the outer side of the bend, and with the rubbing hardness there, it can actually impact the seed as well. So yeah, catching it at the base of the boot after all the impacts. So you might have 2 reverse impacts plus hosing to get down to it. Years ago, shearers used to recommend take the cap off their heads and watch how high the seed would go in the air. If it went more than about 3 meters, back your wind speed off. But they also had a requirement that from that head, the seed hose was going downhill all the way. If it goes flat for a bit and then down, you need more airspeed to make sure it goes there. But if it's a nice downhill run all the way from the head, then you can get away with a bit less airspeed. The complication is if you're putting on 100 of super or something, of course, you need a higher airspeed to keep the fertilizer going. Those with seed and super together, you've got no choice there. You've got to keep that airspeed up. But if you're splitting it, there's a possibility of getting more air on the fertilizer perhaps than the seed. But at the same time, you don't want to have blockages. So everything's a bit of a compromise.
Rob, did you want to add anything to that?
Yeah, I think the issue with the hoses is very hard to determine at the time, because you put them, or you check them as the machine goes into the paddock, but you might do a couple of thousand hectares before you actually get to lupins. And that can be the difference between having a seed hose that's smooth inside or a very corrugated one with the wires just starting to be exposed. And you don't really discover that until very much later, when the hose starts getting so thin it makes a little hole, or at the end of the season when you pull them off to replace them.
Yeah, well, I hadn't thought of the damage from the internals of the hose. A lot of hoses have plastic ribbing as well, not just steel, but if it's wire inside, it definitely would impact the seed more. Yeah, I guess it's one of those maintenance things, I suppose, to check on.
One thing I noticed at Darren this year, that Ausplow have got a heavier duty plastic type hose, so there is no wire to wear out and cause a lot more friction inside.
Okay.
So
yep.
I'll try next time we put hoses on.
Yeah, okay. And I didn't see that. Sounds like, well, anything to keep the inside of the tube smooth would be better, because the seed then is not impacting on anything. And going around corners is always the problem. So if it's smoother, chances are it'll go around a corner easier than a rough hose.
Okay. Any other questions from anyone in the audience?
Can I ask another one? When you're doing high moisture lupins, it's very hard in our conditions to actually find a paddock that's uniform. So you might go from very high, that almost too high, down to, well below your 12%, in the course of, say, a kilometre run. And that's a big issue that I had doing them fairly low rotor speeds, because it's pretty easy to block things up.
Yeah, okay. Well, where it's highly variable, it's probably better to actually desiccate with paraquat or something, because if you really wanted to get into it and get them off before your barley or canola or something, well, then evening it up with paraquat is probably one of the better options, and it also controls any weed seeds as well. But that certainly makes it flow a lot easier and probably less likely to block if all the plant is dry. There's nothing worse than an odd green one, and it comes in a slug, and that's where you can get blockages at low rotor speeds. So having it all desiccated beforehand, because the alternative is, I think that's the problem now, I think most people then just wait for it to dry off, because if you wait, they'll all dry off. But then the first ones get very dry, and that, like in the example there, with averaging 9.5% moisture, well, there must be some in there that are probably 7%. And yeah, they don't like getting whacked around. And they can possibly even get hard seededness, because it takes longer to wet them up again for germination.
Yes, yeah, I don't recall seeing any real correlation there when I put the two together, but yeah, it's obviously an issue.
Rob, around your area, do you see many people desiccating lupins, or they just pretty well wait for them to dry off?
I think now that we've got our radish under control, there's a lot less desiccation on lupins. When there was radish that couldn't be controlled with the brew that Peter Newman brought out with the metribuzin simazine, that sort of made lupins a clean crop. Before that, there was pretty much patches of radish you desiccated to try and get the radish and some of the ryegrasses if you had ryegrass. But it's more canola that gets desiccated to get that off first, or as early as you can.
Yeah, okay.
And I'm interested in the electrolyte solution. What was the recipe for that? Do you recall?
Just simply distilled water, or I guess whatever you buy, the deionized water, just so there's no salts in it, and put it in solution for 24 hours, and then just have the normal salt testing machine, microsiemens per meter per gram, I think it was. Yeah, that's how it was expressed. Yep. And yeah, but there was certainly some of that soybean work suggested it was more important, but of the 5 tests I think Ed did, only 2 of them showed up any significance. We were sort of hoping it might have worked, because only taking 24 hours, it's quicker than having to try and do a germination test. And like you've pointed out, a backyard germination test is just not adequate. We tried our own tests for germination too, but then what it come down to was you can count the number that actually got the radical coming out, but then when we took it down to talk to our people to do it, they said, yeah, but that's an abnormal seedling. I said, oh, what's an abnormal? I said, well, it comes out okay, but then goes abnormal. So if you don't count it as abnormal, you're getting a false reading. So we thought, oh, barley's to this, we can't do this. We'll just get them to do it for the abnormal seed. So yeah, but the electrolyte thing was easy, because it's just simply dunking you in the distilled water. The other thing that is handy for I haven't tried it so much with lupin, but certainly with field peas, that the seed coat is easy to crack, and chickpeas, is a quick test is just to drop, most people have household bleach, sodium hypochlorite. It usually bleaches 4% in solution. So if you get a cup of hot tap water, say 50 degrees, whatever tap water is, 50-50 of household bleach brings it back to 2% sodium hypochlorite. And then you just drop some seeds into that. And if there's any damage to the seed coat, it'll just swell before your eyes like magic, because it just, the bleach just goes in there and swells the seed. It's just awesome to see. But I think the seed coat of lupins is thick enough to probably not be damaged to let that in, where you tend to get more, it's the time factor. I think that the seed coat might be dented and then it's damaged the internals rather than just coming out. And maybe that's why the solution test didn't work so well, because the coat is so thick that you've got to get the internal solution to leak out into the distilled water. But certainly, you know, the 50-50 sodium hypochlorite definitely worked. The paper that I got that idea from suggested just using normal 20-degree water. But I found just the hot tap water just sped it up, because when you dilute it 50-50, it ends up being sort of 30 degrees anyway. And the bit warmer water just makes the seeds swell up so much faster.
Okay. Any other questions before we wrap it up?
This is probably a far-fetched one, but how many lupins, how many hectares of lupins would we have to grow Australia-wide to get the pod guard technology out of canola into lupins? Because I think that's our single biggest cost in terms of lost yield, as well as ongoing volunteer lupin weed issues.
Good question, Mike. Yes. Yeah, certainly the losses. I'm surprised when Chris came back with those loss measurements of like 400 kilos. I thought we were getting that 30 years ago, and we're still getting it. So it is the pods flicking off. But I don't know, the breeders of lupins, I think they're still going for yield more than perhaps that pod trait. But we can only ask them at the field days, I suppose, and see if we can get someone to bite, and if that can be put into lupins. But yeah, that front loss is definitely the highest loss at harvest anyway.
Definitely.
Yeah, I think the results from the overall project, Glen, it was around 8%, I think, from the front, which was the highest of any crop measured.
Yes. Yep.
And a total, 8 to 9%, with the total losses of up to 12% in lupins. So fairly significant amount.
Oh, so there was still 4% going through the machine. I'm surprised at that, because normally you can set the machine pretty good.
Yeah, it was something like that anyway. It was 3 or 4%. Yeah.
But with less stock around, like people say, oh, well, we're just going to get the sheep to eat it. But they do eat it if they're in full pod a lot easier than if they're on the ground. The trouble with the full pod in the ground is once the sun gets on it, they tend to split open. And the seed then on the ground, the sheep tend to pick up the ones they can see and stand on the others. Where in a full pod, they can eat the lot. So some suggest that crash grazing straight after harvest is the best way to get the most of the lupin seed before they all start shedding badly on the ground. But there's less people now with sheep to do that. So yeah, that's a problem. I think it's better to get it in the bin first and then feed it back to them.
Okay. Any last comments at your end, Rob, or anyone else?
No, just we had different issues this year. We had soil type issues. They all germinated on some soil types, and we've got totally bare patches where they weren't exactly happy with their depth on other soil types. But that's a one-off issue, I think, just was drying soil conditions and, yeah, just a particular year problem.
So you're thinking the surface dried out, Rob, so that they didn't germinate because it got too dry at the top and there's perhaps the lighter soil, is it?
Yeah, it was sort of sand over clay for some reason. They dried out. Whether the trenches were slightly more open and they were very slightly shallower, I don't know, but didn't seem to be that much difference when you dig them up. But it's pretty much a line in the paddock where they grew or didn't grow, and it's definitely a soil change.
Okay. The other thing I do suggest with lupins is not to have too much press wheel pressure on them. I tend to back it off to just about dead weight for lupins or any dicot, even canola. Anything that's got to pull its seed coat out through the surface. Don't want too much pressure above the seed. Generally press wheels are about 4 kilos per centimetre width, and I tend to back it off to about 2, which is about the dead weight of most press wheels. But in some of our other lupin work, 0 was as good as no pressure, or no pressure was as good as any pressure. Because I think it's just, if the surface gets too hard. And the other problem is it's pressed, it can actually wick the moisture out, so it can dry out quicker if it's pressed. So I tend to use a ring harrow behind the press wheels just to bring some loose soil back in on top to stop that wicking problem. But wicking is not necessarily a problem on the lighter sand, it's more of the clays. You get wicking of moisture out. And we're actually trying a coil press wheel this year too, because it seems to do the best of both. It still presses around the seed, but leaves it less crusty on the surface. So we're going to try that for particularly our heavier clays anyway, but it could be an interesting all-rounder as well. So we're experimenting with that this year.
I think we might wrap it up there. Thank you, Glenn, for your time today and preparing your presentation. And thanks to GRDC for funding this work. And we will call it a day. Thanks everyone for coming along. We will post this up online, so if you want to go back and have a look and at any of the details or share it with your neighbour, it'll be up there on the Liebe website. So thank you.
Thank you, Chris. Thank you.
Thanks, Chris. Thanks, Glenn.
No worries.
Thank you.